Check out all these different batteries. This alkaline battery powers everything from toys to flashlights, while this zinc air battery powers a hearing aid. This rechargeable lithium-ion battery is vital for electronics like game consoles. This one powers a smartphone. They may come in different shapes and sizes, but all batteries operate the same way. They depend on a chemical reaction to occur within them that produces an electric current. This is a branch of science called electrochemistry. All batteries require three things to function: 2 electrodes and an electrolyte. An electrode is a conductor that carries electrons to or from a substance. In a battery, there are 2 electrodes: an anode, which produces electrons, and a cathode, which consumes electrons. Because electrons are produced at the anode is labeled the negative electrode. And since electrons are consumed at the cathode is called the positive electrode. The final part of the battery is the electrolyte, a substance that allows electric charge to flow from the anode to the cathode. A battery is actually a pretty simple device, simple enough so that you can make one out of some common household items. For example, I have a lemon, zinc nails, and copper wires. The juice inside our lemon is citric acid. It's going to serve as our electrolyte. The zinc nail will be our anode. It will produce electrons. And the copper wire will be our cathode. It will consume electrons. Okay, let's build a battery. First, I'll push the copper wire into the lemon. Now, I'll push the zinc nail into the lemon. All right, now let's connect our voltage meter. The anode, our zinc nail, has a tendency to give up electrons more easily than copper does. As the zinc nail comes into contact with the citric acid, it reacts with the acid, producing electrons in the process. As the reaction proceeds, positively charged zinc ions move into solution, and the electrons that are produced flow to the copper wire. The meter is moving, so we are generating some electricity. So do you think this amount of energy is practical for any real-world situations? Definitely not. Massive pieces of equipment, such as cell phone towers and power grids, need a steady stream of electricity to consistently function 24 hours a day, 7 days a week. Electrical engineers are responsible for making long-lasting energy sources. And don't you get annoyed when the battery in your laptop or phone dies just hours after you've charged it? This is one problem engineers are trying to fix. Right now, those lithium-ion batteries last just between 1 and 3 years after you start using them. Research and testing of new materials for electrodes is ongoing to extend the life of a battery, so we aren't constantly looking for electrical sockets. Okay, now it's your turn. Do some research to see what other materials you could use for the anode and cathode. Then, make your own lemon battery and see how much electric current it produces.